Ooh. It's in the 70s, I guess. It's like crazy. Off my poly, don't have all of the, some of you may have gotten grades on the project. I think, I'm not quite sure if it's majority yet or not. A few still have been coming in. So if you haven't actually handed in your project, it's not too late, but just get it done, get it out of the way. Don't spend a lot more time on it. We want to move on to the next project. So the ones I've seen so far look pretty good. You know, it's you know, some were good starts, some were more fully developed, and that's totally fine. Let's see. Let me get what I need to do here. Sorry, I'm just trying to get my act together. Slightly changed my whole setup here, so that was the one big accomplishment, I guess, over the spring break. Shouldn't look any different than you. Look any different than it did to you, except for maybe a few things today. We'll see how that goes. I'm hoping this afternoon will be a little bit more organized than my morning lecture was. A little bit. I, in the meantime, created a whole bunch of new slides between now and then because I figured it would be better with a bunch of slides. So there's that. Okay, now. So project 2, project 3, project 1, all out of the way, right? 1, 2, 3, out of the way. We're all about project 4 now. And one other bit of business, which I'll also set up here. Let's see, make sure I got the right screen. And let's see, maybe I'll even try to get my, oh, that's slightly busted. Yeah, I'm having to sort of rebuild a couple of things inside of OBS. Some crazy reason. It doesn't want to delete that. There we go. Let me add my video capture device again. Not super huge. About, of course, is now roughly here. We're actually here. Hopefully, is that showing up on the screen? Can you see that? Can you see the yellow arrow? I'm just wondering if now suddenly that's not being captured by. Okay, all right. It's just a small version on my screen, so I wanted to make sure. Actually, I should just like do a crazier, bolder color, and then maybe I'll be able to see it. Yep. Okay, and maybe a bigger. There we go. That'll definitely show up. So here we are today, studio class. We're gonna start mostly talking about kicking off the platformer project though today, and maybe we'll have some time for you to start working on things. If not, we'll at least cover a bunch of kind of key things, the key things that I think are important to creating a platform game that is compelling to play and interesting, and kind of in some ways it can be class, in some ways it can be derivative or whatever you want to do, but a bunch of stuff about platformers specifically. And also there's this issue you may have heard by now, or maybe up on, I think it's up on SIS somewhere, about a schedule check for those who, with the lecture notes and keeping up on attending. That would be it's usually kind of short questions, multiple choice, nothing too stressful. It's a small portion of the grade, but it is sort of the participation version. So the best prep for it, other than to have been here for the whole semester, of course, is to actually probably review the lecture notes. We'll be talking, a lot about concepts. If I say, well, what's the difference between a collider and a trigger, for example? What's the difference between a kinematic and dynamic rigid body, for example, or a static rigid body, right? If I want something to move, I use, questions like that. Very kind of basic. If you've done the projects probably. It's also sort of a bit of a sanity check with regards to making sure that you did the projects yourself, as opposed to just having copied and pasted from somewhere. Not that anyone would do that, of course, but. So the quiz is more a sanity check than a, final culminating accomplishment. It's just that portion. More important is, of course, the final project, where this is your big chance, right? If there was anything about any other project that kind of didn't come up to snuff, or you didn't feel that you were able to demonstrate, if you said, well, okay, I never used a code routine, but I know that's really important concept, so I therefore want to make sure I use a code routine. So that, the final project is really meant to, be the standout one. It's not like crazy heavier weighted than the others, but so if you've done well on all the others, keep doing what you're doing. If there was a particular area where you felt like you didn't show things in their best light, hey, you can always try to shine on that final project. All right, so that's kind of where things are on that. And let me get back here. So today I want to kind of kick off a little bit more about platformers, right? So what do I platformer? What exactly do I mean, right? There's a lot of, the traditional platforming games way back, probably I would say the first platformer to me that I think of, is Donkey Kong, Mario, let's see, I guess Donkey Kong would be one, Joust would be certainly another, in the home versions, clearly all the Mario games, the Sonic games, and so on. It is the 30th anniversary of Sonic this year, so right. Oh, the audio is cutting out? No? I can try to pull this a little bit. Let's see. Just in case, I'll pull my mic a little bit closer. Hopefully not destroying my desk while I do that. Okay. Do that. And so the key thing about the motion is that it's a combination of kind of very controlled motion and as well as physics, right? The classic thing, that the platform thing is more about, traditionally it's jumping from platform to platform, moving from platform to platform. It's kind of the idea. Let's see if Unity will behave itself any more this afternoon. Then I think the moment I start streaming, it's been getting kind of heavier and heavier on poor Unity here. And all right, so here is my little tribute to Sonic. I'm using the Knuckles character. And even though, I got to get rid of this. I got to get rid of this one silly thing here that I added to the tile map for the other class, and it's just not going to work. If you were in a 3D Crash Bandicoot, good case of it, or any of the more modern Mario games and so on. You typically are moving around a plane of some sort. You might be moving around in 2 dimensions, or maybe you're just moving left and right in 1 dimension. You have this notion of hopping up, jumping up, so that you are kind of moving in the world, sort of under the control of physics to some degree, right? You have to hop from one platform to a platform. Maybe you can fly, maybe you can do something, but there's always this kind of physics aspect that you have to deal with in order to kind of move around. So it's, you're in control, but you're not entirely in control. And in my version here, I've been really trying to go for a very Sonic vibe, which means it's very dynamic, very physics-based. As you roll around, as you move around, you have this kind of bit of a pinball sort of feeling to it. When you jump, you get a real, dynamic sense of things. We kind of move around, we bounce. So there's this notion of jumping up. We can kind of grab onto things. We can, kind of be propelled by the little platform-ish kind of stuff. And we're always, doing this half in control, half out of control, spinning around, and so on and so on, right? So the moment we leave the ground, we're sort of at the mercy of physics a bit, right? So that's, to me, that's kind of one of the determining factors on a platform game, right? There's this idea of jumping from platform. Have to get from this platform, say, over to this platform. Maybe there's a couple of different ways I can do that, but you get the idea, right? And The other thing that's kind of changed these days about platform games is that they typically are multi-screen like this. There's way more than will fit on one screen here. And there's some sort of camera control, some invisible cameraman that's doing its best to kind of keep things centered in the screen. But it's not just following all the time. I mean, maybe you could certainly do a real simple camera control that just locked itself to the player as well. How much that's really sort of a determining factor in platformer versus not, I don't know. But these days, most platforms are larger than one screen, so that's another thing we want to do. Some kind of camera control, and so let's see if I can get myself forces down in here. So one of the set of magnets that are up in the ceiling and dragged up in, and they haven't been really firing the way they used to. So let's see, let me increase the magnetic force here. We'll go to them real quick. So yeah, you can see there's design to the world, right? You're moving throughout the world. There's going to be certain things that we deal with. There are effectors that kind of move us in various ways. I have these magnets up here. Where are my magnets? And I'm going to make this magnet. This magnet has an effector. It is a buoyancy effector, actually. And it draws things up towards it. Let's see, give it a bit more, say 200, not 2,000, 200, whoops. And now I'm on top of myself. All right, I'm gonna turn the camera off now, of course, so that you can see what's what here. There. All right, so I'm changing the flow magnitude of my buoyancy effector here, and I'm gonna increase sort of the range of my box collider that it uses, right? So I can set this area of effect, and I'll go up here, change this one again, make its area of effect a little bit longer. So it sort of becomes this sort of tractor beam that I can run around, get caught up in, things like that. So the environment, you're running through this whole kind of rich environment, sometimes in complete control, other times not in control. And we are dealing, generally you deal with all sorts of, I don't have any enemies in here yet. Let's see, here we go. There we go, zip, right up to the ceiling. And if we jump down and we go past here, we can run underneath there. But if we're jumping, I gotta try to kind of avoid that one easier than the other one. Jump, there we go, got a little bit of lift from it. But anyway, on and on and on. And there's a few other kind of physical elements, like there's even a whole set of tiles in here that are whoops, I had a bug here, that are set on springs. So it kind of adds to the fun of trying to navigate around. How do you deal with things that don't move the way you expect them to, or they sort of do, but they sort of don't. And yeah, like I said, my version is very physics-based. Does it have to be? No, not exactly. You could do something that is far more deliberate. And there's actually a great example that I posted as part of my lecture notes and part of if you've been watching the channel, someone did a great kind of walkthrough emulation of how they would implement a very Celeste-like control, jumping around on platforms and wall jumping and all that sort of stuff, in a video on this great channel called Mix and Jam, which I just discovered. So there's that as well. So let me get back again. Sorry, whoops. I clicked on something that I shouldn't have. Someone distracted me. All right. So let's dive in to the lecture notes. Now that I have them, I'm all excited. All right, some more lecture notes here. All right, so grounded platforms, up, down, sideways. Right? So it's all sort of about how you interact with the environment now. The environment is not just sort of something that contains, but there's way more possibilities for interacting with the environment on this game. That's what I'm looking for, right? So let's talk about first, okay, how does the typical character controller work? We'd love to start with a character controller in the games and say, okay, let's move an object around on the screen. So let's imagine for a moment in an idealized platformer, what would we do? Now, obviously, this whole notion of respecting gravity is something I like to play up, right? You only should jump. You should only be able to jump or move left and right when you're touching the ground, right? You have this relationship with the environment that was, it's far more obvious than it was in the last game, where it's just top down. You're always touching the ground, right? Now we want to say, okay, there's certain things you can only do when you're on a platform or on the ground. Otherwise, your behavior is far different. So let's imagine in our update, we of course always get our input vector to figure out if we want to move horizontally or vertically. And now we also want to do something where we're going to have some sort of button somewhere that says, okay, we hit that button, we want to jump, right? So here in our update routine, we'd have those two things. We'd grab an input vector and we'd have some sort of jump indicator, right? So jump is a momentary action, and the other one is just, kind of a continuous control. Now, then over in our fixed update, we want to respond to that. And somehow we want to say, well, if we're on the ground, then we're allowed to move, right? We're allowed to do things, because the only way we can kick off something, we can walk, we can jump, is we have to be in contact with something. Now, I'm not saying this is, it's not a written in stone. That's why I'm saying the most basic 2D platform character controller. I mean, there's other things where you can do things like double jump and jump in midair and give yourself a boost and do all sorts of different things. And that's what makes different platformers interesting, right? The way they do things, the way that jumps are handled. It's not always just the same thing. But here we're talking, really, really stripped down. All right. So we said, okay, if we're touching the ground, we want to be able to move, say, left and right according to the joystick, right? Left and right horizontal. That makes sense. Now, you'll notice in here, I'm saying, okay, rigid body dot velocity. I'm setting the velocity equals the X direction of my input. And I'm setting rigid body dot velocity dot Y just to rigid body velocity dot Y. I'm keeping it the same. Why is that? That's so that I respect physics, right? If I just set rigid body dot velocity to be my input vector, and I wasn't pressing the keyboard, or I was pressing the keyboard W and S, I would either be moving, I'd be, floating because I'd be, counteracting gravity, or I'd be acting in the direction of gravity, or I'd be setting the velocity to 0, which would also counteract gravity, right? So if I don't respect what's already in rigid body dot velocity dot Y, I would be countering gravity. Suddenly my character would float, like things wouldn't move around. So that's the key way to sort of respect gravity. And the other piece is to say, well, if someone asked me to jump, well, then I should do something to give myself some momentary upward direction, some force upward. Now, I'm doing it this way because I think this is how they did it in the, I forget now. I think this is how they did it in the Celeste video, and it's a valid way to do it. I'm momentarily adding to the what we would call an impulse, right? It's an instantaneous change in velocity in some direction, in this case, up. And one important thing here, you notice it's a little different how we're handling the input vector versus the jump button, right? The input vector is being continuously checked and continuously put in here, whereas we're not directly putting the result of input.get button down into jump. Can anyone tell me why? Why I might be doing that? Momentary silence. Why would I do that? rather than just saying jump equals input dot get button down jump. Physics. Well, not quite. The update function is more frequent than fixed update. That is correct, right? So what has to happen here, so you want to separate your input loop from physics. And now it's a combination of those two things, right? Because I get the input here, but if I just said jump equals input dot get button down, it's still, the actual action would be down here in fixed update. But this routine up here, the in update or the update piece of it, that could be running at a much higher rate than my fixed update. Like on my computer with a fast screen, this might be happening over 100 times a second, whereas this is only happening at 50 times a second. So it's possible that this input.get button down will switch from the first time it caught it, right? Because this is only true on the first frame that the button is down. And then if I manage to have this, if this is called again before fixed update happens, it will then say, well, the next frame, that isn't true. So it'll set it to false if I didn't do it this way. If I just said jump equals this. Excuse me. So by doing it this way, I guarantee that this is not going to be set back to false until I've actually jumped, until I've given that force, right? So this is sort of a safe is pressed, but make sure that you do jump after the button is pressed so that you don't accidentally set this back to false again before your physics loop has a chance to run. So do be aware of the fact that these loops are running potentially at different speeds, right? That's one good case. I've definitely seen where people would say, well, my jump, sometimes it doesn't happen. Right? Why is that? How come my jump won't happen? And it just happened to be because your game loop was running fast enough that this would happen twice before your fixed update got to happen once, right? It's a good thing to worry about or to know about. Don't worry about it. Don't let it keep you up at night, but do be aware of it. All right, so this is pretty basic, but it should kind of get the job done. But the big question, of course, is what is grounded? When do we decide that we're grounded? When should we be checking for that? How do we know we're touching the ground, right? Is that as simple as a collision with a ground object? Maybe. Run, walk, jump, maybe, when touching the ground, it's a design decision, right? Related issues, can the player do things like double jump in the air? Maybe they can jump twice, maybe they can jump once. Can the player climb or run up walls? What happens when they're hanging onto the wall? Do they slide back down? That's a different behavior than when they're standing on the floor, right? Can the player hang or shimmy overhead like we did in the like it's doing in my little Knuckles Sonic game here, right? So it's all sort of up to you to decide. And a lot of these decisions are going to, work their way into your decision about, how you want to handle this groundedness, right? So how do we know if we're grounded? And the idea is we need to somehow check something. There has to be some way, that we can say, yes, we are connected to the ground, right? Pardon my electrical pun, but that's the notion. What is it? How do we know we're touching the grounding rod on the floor there, right? So one of the things you first consider is this is going to make you go in one direction or the other. Is like how is the environment built? What did you do? How do you make the environment? One of the simplest things to do is you have some sort of platform, throughout here that is made using a tile map that has a collider on it. It has probably a tile map collider and probably also a composite collider to make sure everything is as smooth as it can be. And that becomes your ground layer, your physics. You might have it as a physics layer that's grounded or something. And you're going to have some questions or some questions to answer, I should say. Do you want everything to be just one ground layer that the player then just, as soon as they're touching that, that they are grounded somehow. They're touching the environment, right? Their behavior changes. Or Do you do things like have a specific ground tile map and walls tile map and ceiling tile map? So you can say, well, if I'm colliding with something, right? If I'm choosing that as my means to figure it out, well, it's going to be tricky if there's just one sort of collider that's just the ground and I collide with the ground. How do I know if I'm facing up? How do I know if I'm, hitting that thing from below or from the side or sort of things? My collisions get a lot more interesting when I'm trying to use them for that. So you have some decisions to make on that. So you can also use orientation to help you decide. You don't necessarily need to have walls and a ceiling, and you need to have something for the collision. Touching anything might cause grounding, right? Or cause it to be, check, is it, climbable? Is everything climbable? Is everything hangable? Is everything groundable, right? So for that, depending on your approach, you might need to do just a little bit more math on your own behalf, as opposed to just saying, okay, this object on collision enter, ta-da, I collided with the ground, right? Going to be a little bit more sophisticated. You have to say, okay, what did I collide with? How did I collide with it? What is the orientation of the player and so on? That's something else to consider, right? If the player, like in Sonic or Knuckles, can the player actually roll? Is it using a circle collider that can roll, in which case the orientation of the player is changing all the time, which is another thing to consider about how you do your game. If you take, I recommend it's your first time doing it, definitely take a simple approach. Don't let the player rotate. This way you can kind of manage things. But if you want to get ambitious, there are ways, some that will handle it, some that don't. So let's talk about some of the methods, and they're all kind of, at least in some ways, related to things that we have seen or talked about a little bit. Right? We've seen ray casting. We've used ray cast or perhaps line cast to figure out, all right, can an enemy see the player, right? Because we want to, if the player is, start using, imagine the player is here and the enemy was here and there was a wall in between, right? We used our ray casting to say, all right, enemy, cast a ray, and what was it that you hit? Right? We never got past here because we hit this object with the ray cast. All right. So we used the physics engine. We used likely physics 2D ray cast to hit that object, right? So we're interacting with the physics system to give us that information about what this ray hits. All right. So why not just go ahead and say, well, continue to use ray casting. I have a player here. I know the center of the player, the belly button of the player. And I can just, as we say here, from the transform position, now I'm using this vector 2 dot down. You might have noticed we usually don't have a down vector, right? It's a little bit redundant. We have an up vector, we have a down vector. So it's just shorthand, but you can only use this with a vector 2 or vector 3. You can't use this with your transform, right? Because transforms only have, a XYZ system. They don't have a X prime, Y prime, Z prime sort of in the opposite directions, right? We don't have negative axes. So in certain circumstances, though, it's convenient to have this kind of shortcut here. You could always use negative vector 2 dot up if you wanted. Yes, you can certainly, as Dylan is asking, can you do minus transform dot up? You could. Now, it's an interesting point. We'll make this a couple of times, perhaps. You'll notice that I'm using vector 2 dot down, or I could use vector 2 dot up, or I could have said transform up, which is probably, here's our Knuckles and said transform up. That's pointing this way. I could say negative transform up. That's pointing down. Okay, that's the right thing. However, if Knuckles is allowed to turn into a ball and Knuckles is allowed to roll, right? Suddenly, as he changes orientation, his up vector would be this way and his negative up vector would be that way. So even though he might be touching the floor, right, the ray would be cast this way because he's rolled, right? If he is rotated, that's something to be aware of, something to be careful about, all right? So that's why sometimes if you want to just see in the world, what is underneath your character in the world, it's convenient to use that vector 2 for that, because it's always down with regards to gravity. It's the same direction gravity points in, right? So it doesn't make it not useful. It's still very useful. Do it this way. And we also we can use, like in this case, we have the, whoops, I have a mosquito. Wow, it must be spring. We go, there's lots of different versions of raycast as well. We're going to use the particular version that we start with a position, a direction, a distance. So we're just using a distance of 1 here, which happens to fit our player roughly, right? This could be scaled to whatever you need it to be. It doesn't have to start from the belly button either. It could be just like, you could have an offset and here's the ray if you like, that sort of thing. But so that we have those. And then we have a layer mask. So we can say, well, what things are we interested in hitting? If we're not interested in hitting the ceiling, if we're not interested in hitting enemies, we can just say, all right, just collide with the ground. This would also be handy if you said, okay, I do have a ground tile map, I have a wall tile map, I have a ceiling tile map. You could just have grounded be when you collide with the ground ones, as opposed to this ceiling or overhead or climbing whenever you're hitting a ladder. Potentially do that. Now, if you're using raycasting, one thing to be careful about is that a ray, you have to remember, a ray is just a sliver. It's just a tiny thing, right? It has no real width. It's just a line that points really straight down, and it's going to hit, right? It's just a sliver compared to the point of contact, potentially, like if this is a box collider, for example, or even a circle, right? So that being infinitely just tiny here, and potentially having a certain type of relationship with the collider of the player, it can lead to false negative results and stuck objects. So what exactly do I mean by that? Well, I'm drawing a lot now. I like this. I like drawing. Imagine I have a box collider, and that's my player, and here's the center of my box where the player is, and I point that down. So I say, okay, anything below there, and if the ground is normal, but if the ground was here, right, say my platform was in this direction, there's a tree. In this case, this would say, okay, you are not grounded because you're right on the edge. Now, if this isn't allowed to rotate, it would still sit there. It'd sit there just fine. Physics would let it do that, especially because you could be like right up to the edge there, but then suddenly this would think you were kind of floating. So your player would suddenly get stuck moving to the edge if there's just a single ray. Okay, so that's kind of one thing to watch out for. Sometimes they'll do things like, you'll see things that'll cast multiple rays, right? Then you can figure out if you're teetering off an edge, for example. We'll take a look at that a little bit as well. All right, so raycast, that's one. We've seen raycasting for our occlusion, so you might be tempted to use that. It's certainly valid. You can do that. You just have to be careful, right? Another popular one, and this one is the one that the Mix and Jam uses, is an overlapping circle, right? We also demonstrated that when we were spawning enemies, right? It was useful for that when I said, okay, I want to spawn enemies and I want to see the potential spot that I spawn this enemy into the scene. Is it going to collide with something that's already in the scene, right? So I would do a physics 2D overlapped circle at whatever position and would say, if some object were, whoops, what happened here? If some object were here and I do a circle cast to see, okay, is it okay for me to spawn here? Right, this area would say, oh, wait, you are going to collide with this, so don't don't go there, instead try again, and maybe you wind up over here where you don't collide, right? There's no, what happened? I jumped forward a slide. Didn't mean that happen. There we go. Back to overlapping circles. Suddenly, like my code is all different. So we can use circle collisions to kind of figure that out. Now, one of the most basic ones is to say, okay, cast a circle at the player's feet, or even just cast a circle around the player and say, well, what does it hit? It has to be bigger potentially than the collider, so we know it's actually going to hit something, right? If the player's collider itself was that big, we have to make sure, that our new circle is outside of that, so we know where to catch something. But as long as it catches something, right? In this case, the simplest case, transform.position is the center of our circle. The radius of our circle is 1. And once again, we want to say, let's hit anything that is on the ground mask, right? And you could do multiple ones. You could say grounded, again, overhead, left, right, climbable, whatever, depending on how things are. You may also even do things like maybe you use 4 cardinal directions. So instead of saying, okay, am I colliding with the floor? Am I colliding with the wall? Am I colliding with the ceiling? You might say, okay, I cast a circle at my head. Do I hit anything? I cast a circle to my left. Do I hit anything? I cast a circle to my right. Do I hit anything? Do I cast a circle at my feet? Do I hit anything? Right? And that'll tell you I'm grounded, I'm overhead, I'm right, I'm left. You can even do, other sorts of things with that, right? And again, you can even get fancier to say, okay, have 2 feet. So if you're close to the edge, you can teeter on an edge, right? So this is the basic way to do the overlapping circle. All right. Now, things you never, or maybe some of you have, or we've been using colliders a lot, right? We've had collider 2Ds, and we've done on collision enter and so on. But you may not have actually done much with the collider itself, or the collision object, or the things that are being passed into the on collision enter and so on. So we can actually get fancy with those as well, right? So when we have a collider, now imagine this is the collider here that is, why did that? I think I must have a gesture set up here. Maybe that's it. Is a circle a gesture? That's weird. Try that again. Yeah, it is. Weird. Huh. Stop doing that. All right. So we had an overlapping circle if we want to do brute force. Now, when we have a collider, we have a collision that takes place, we can actually ask to say, given this collider, given any particular collider, say, okay, is that collider touching any other layers? So, for example, if I just have my one main collider and I have an on collision enter event, or even in my fixed update, I can just say, oh, by the way, is my collider touching any other layers? And that could be used to say, all right, if this is true, that means, yes, I am touching right here, right? This somewhere, right? Could be anywhere. If I had, if it was this way, doesn't matter what. It just says, okay, I am touching somehow, right? These would all return true. And you could say, well, which layer am I? So it's pretty cool. It doesn't exactly tell you who's hitting where, but it can be another cool part of the puzzle. Right? There's another bit that you can get from the collision and colliders. You can actually ask to get the contact points, to get the points of contact here. So not just is it touching that layer, but you can ask it for precise information about how it's touching, right? The specifics for the point of contact. And this is great for determining up, down, left, right, or even diagonals, right? Because it's going to tell you the actual geometry, the actual point here, right? So if we happen to be, somehow we manage to be on a ledge, we'd get this point over here, right? If we happen to be on an overhead, we would get this point over here. And they're all going to have a certain relationship to that center point there. Or even they're going to have a relationship to our up vector, right? So we can do lots of things like figure out an angle that we're hit at. So we can figure out exactly where on the circle collider, or exactly what angle we're being hit there. Right. And the way we do that, some of these require a little bit more, some of the Unity interface gets a little bit kind of convoluted. And the idea here is that you have to set this up a little bit more. You say, okay, here are the contact points. Here's an array of contact points that I'm potentially interested in. We'll allow for up to 4 contact points. And it will return, okay, how many contact points do we actually get? And we can say if they're greater than 0, then we can look at the information that's in the contact points to say, okay, if the point of contact was below the belly button, below the center, right, of the character here, right, below the middle of its collider, by at least 0.1. So it's not right at, it's got to be below. I want below because I might also have above, right? So this here would say check the point of contact that was 0.1, at least 0.1 below the center of the hero. So that would tell me that, yes, there's something below me. And I have a little bit of math that also compared the X direction, the Y direction, is it above, is it below, what the angle is, and so on and so on and so on. So get contacts is a very powerful tool then. So another thing that you can do, and this is the one I'm currently doing. It all kind of depends on what degree of control you want to have, what degree of information you want, right? So to avoid things like the false negatives or, having to decide, all right, exactly what size am I doing a circle? Is my circle big enough? What size is my character? Is a radius, 1 meter radius enough, and so on. You can also, instead of casting a ray or casting a circle, you can cast the collider itself. So you would take the collider, like in this case, it's a capsule collider. It kind of looks like a circle. It could be, any sort of collider, and you cast the collider itself, right? So what that means is you've got the collider, here's the collider, and you start the collider at a certain position, and you move the collider. So it's as if you're drawing it over and over again, forming, a path. You're moving the collider along a path and seeing what does it hit moving along that path, right? And it will return what it hits along the way. And you can then check and say, okay, did I hit the ground? What did I hit? Right. You determine, how far you cast it and in what direction you cast it. So like here, for example, again, using vector2.down, and I'm saying, okay, move down by 0.25. So I just slide it down just a little bit to see, is there something beneath the feet of the character, right? This one also can get a little bit fancier with regards to, setting up some filters and, information you get. Why does the raycast array have a size of 2? In this case, I just wanted to have it, I think, could I have gotten away with just having it a null? Some of these functions fill in an existing array. So you can say, okay, if I pass in a size 2, it will give me at least 2 of them. Others, I forget just off the top of my head if this one is smart enough to say, okay, I'm just giving a pointer back and it will arbitrarily fill in. So some of them you have to give it a pre-sized array. Some functions you can just pass in that to. So I use this kind of over and over again. So just in case it didn't, you'll notice like it passes hits in here, but then the number of hits is over here, right? So it might say 0, And in that case, it hasn't written any in. Right. So yeah, it's sometimes it's an easy way to say, oh, only check for the first 2 hits as opposed to checking for 1,000,000 hits, right? So some will be able to do that. Be careful as you read. I definitely recommend you check the documentation on each of these things as you start using them, right? There's definitely some subtlety to these, right? So those are some of the key ways to do it. And there's, I'm sure, plenty more that I, either haven't thought of yet or haven't encountered yet, or somebody else is just, coming up with. And there's lots and lots of ways to check the relationship of the player of 2 things as they collide. Where are they colliding? How do they collide? What angle did they collide at? So on and so on and so on. All that information is there. So the next question, of course, is, well, when do you check that? Do you use on collision enter, on collision exit, on trigger update, fixed update? Where do you use them? Right. And there's not particularly one right answer to that. The most efficient one is probably on collision, because it only happened once when that initial point of contact is made. However, you may be getting situations where, here's the good example, like say you're using these things to say, all right, here's your floor and here's your wall, and you're checking both for groundedness and you're checking for whether or not you can climb. Okay, so your character starts over here and your character touches the ground. So on collision enter 2D occurs, and you get a point of impact right there, and you say, great, I am now touching the ground. Now, the player is allowed to move our character in this direction. So it slides along. I don't get a new collision as it moves along the floor because it has never left contact with that. So I get all the way to this point right here, get a new on collision enter because it's not actually a new, I never left. I have to get a little bit tricky. You may need to use on stay or on collision 2D stay, which means as long as you are in contact with this, you are checking, right? So then if I slide up, for example, it would transition and give me the proper grounded while I'm sliding along here, and then climbing while I slide up there. Right? So you have to be aware of the potential kind of subtleties to that. So you might be using on enter, on exit, on stay, or you might just be calling it inside of fixed update over and over again, saying, okay, what are my colliders touching? Are my colliders touching anything? Thereby sort of bypassing whether or not you even need to use the on collision enter, on collision exit, on collision stay, right? Because you can always check, is this collider touching something? Kind of cool, right? Kind of a way to kind of bypass some of those events if you don't want them or you want to do something different to them. So where, when, and how you do the checking will impact how responsive it winds up feeling, right? Especially if you're not using just the traditional on collision and on trigger events. All right. You may need to get fancier, especially if you want like edge behaviors, like our good old friends, here's Sonic and Tails, and they're kind of right at the edge of these platforms. So they're kind of doing their teetering, they're wobbling around, right? So for them, depending on what their colliders are shaped like, do we need to, what's the relationship between the center of mass and the edge? What do we need to cast a couple of different rays out? Do we need to cast things out in different directions? And so on and so on, right? That can help you decide that. You see a fair number of, I've seen a fair number of implementations where people would say, cast out, 2 things to say, okay, if both of them don't hit, I'm at an edge, and I can figure out what edge I'm on. Right, so you see that sort of thing, how fancy you want to be. Right. So let's see. Now, for the too long didn't read version of the lecture, if you're just looking at the notes, well, there's another version. If you just review, there's another shorter tutorial about casting, climbing, and overlapping that you can check out that I did. there's a bunch of situations where if you are even doing things like using multiple colliders, I think we're actually good on time, so I might talk about that as I start looking at the other one. So you can use multiple colliders to potentially tell, what area are you on, or multiple triggers, right? If we enter a trigger we're touching a trigger that's at the character's head, do one thing. If we're touching a trigger that's at the character's side, do another thing, and so on, right? And also, recommended reading, if you want to implement one, if you're a fan of Celeste by any chance, the mix and jam tutorial here is a really good one. Just kind of goes right through that specific case and how they did it in general. Right. So, any questions on any of those? Let's do this. I guess Polbot didn't. I thought Simple Poll was acting smarter than that. So you don't have to say no. If you have a question, type out your question. All right. So let's look at some code, and we'll also look at my camera mover, right? How we did that in here. So it looks like there might be a question. So hold on for just 1 second. Give me a chance to sip the afternoon coffee. For having a collider for each foot, how do they get placed where you want them? Well, let's see. It all depends. I mean, typically the groundedness is sort of a brute. It's kind of a brute force thing, right? Normally, like even the case of Knuckles here, where I think I've set him up with potentially, I can see him in this. It has a couple of different box colliders around. And it's really up to me. I start off with that relationship. If I wanted to split this and have multiple boxes, I don't move them as the character animates, right? They just move with the character. So it's it doesn't have to be super precise. It depends. Now, as you get into, very, fully articulated 3D models and so on, then you're going to be using more sophisticated ways of doing this, and more sophisticated, collisions and so on, right? So this is just, the first version. Everything else sort of builds off of a lot of these ideas. We have to figure out, okay, the points of contact. And even most of the time when you have more elaborate models, you'll have some simplified version of the model that is using, bounding boxes and collisions and so on. And those are going to kind of work things out for you. But it is fundamentally, it's all about points of contact and how you respond to those contacts. So like in this version where I think the first time I did this, I without knowing a lot about the context, I said, okay, I'm just gonna do a bunch of colliders. And the challenge with this, of course, there's a bunch of challenges. The least of which, or not the least of which, is what happens when this happens, right? So if my character rolls, the left and right colliders or triggers are now the top and bottom colliders. And so it's kind of a little bit, I'm not as much of a fan as I used to be of having discrete colliders for left, right, up, and down. But you can do that sort of thing. And your code winds up, I actually did the code in every possible way to kind of just sort for practice here. So my platform hero controller, I did it. Let's see, did a raycast version, a contact version, a collision version, et cetera, et cetera. So the first version, I could say, okay, am I grounded or climbing? Depending on, is there an overlapping circle that collides with the ground, or does the overlapping circle collide with the walls? And I had discretely layered, I had tile maps that had different layers to them, right? So there's a ground layer and a walls layer, a ground tile map and a walls tile map. That was one way. Or I could do the same sort of, instead of checking with an overlapping circle, I would check, okay, does the collider that belongs to the player, is it touching, right? Is touching layers? Is it touching the ground, or is it touching the walls? As okay, if I'm touching either the ground or the walls, now I'm going to make these decisions based on how I cast things, what direction I cast them in. So I would say, all right, here's my contact filter. Now I'm going to try casting my collider down, see if that hits. I'm going to cast my collider up, see if that hits. And I'm going to cast my collider left and right to see if that hits. Right? So this is collision casting here, or collider casting. Right? Those are three possible ways. And notice they're not in on collision enter 2D or anything like that. They're just directly, potentially in my fixed update, just checking all the time. So that's one method. Next method, checking the raycasts. All right. Raycast down, 1. See if it hits the ground or walls. Overhead, up, 1. Does it hit, and so on and so on. Right? So that's yet another way to do it with the raycast. Then, getting fancier, using the multiple triggers, or the multiple triggers, multiple colliders. I'm actually asking in my on trigger enter 2D, because I know, okay, one of them, right? It's not going to give me a separate trigger for each of those 4. It just gives me anytime I collided with something, or I triggered something, or something triggered one of my triggers, I get this event, which is a little bit brute force, but whatever. I would say, all right, let me check. I'm going to get a list of my colliders, or an array of my colliders, and I'm going to check them. I know that 1 is the floor, 2 is the ceiling, 3 and 4 are the ones that would touch the walls. So I would check, is that collider touching those layers? Right? So it really doesn't matter if it's a ground layer or a walls layer. All that matters is which of the colliders is touching what. Right? So nice thing is I also could get potentially, I could be grounded and climbing, which means I'm touching something on one side and the floor, and vice, similar with the ceiling and left and right. All right. And you'll notice in most of these cases, when I have an on trigger enter 2D, I'll have a matching on trigger exit 2D that calls the exact same function. Right? Or even on, I guess I don't have it on trigger stay, but so this way I'm going to trigger on either case, entering or exiting. So this one would potentially be, well, this would be problematic if I slid along and then went up, because I would never exit the trigger, right? So I need to fix that one. I fixed it for the collision state, where we on collision enter, on collision stay, and on collision exit. They all kind of work together, right? So the on collision versions, they went a little bit further and would look at the colliders and see what are the points of contact for each of those colliders. Or actually, this uses just the first collider that it finds. It doesn't use all those colliders. It just uses the real collider, right? Which is just a capsule collider. And it says, okay, what are the points of contact for the capsule collider? And it checks, is the point of contact above the center of the player? Is it below the center? Is it left and right of the center? And so on, that version. Now, the further down in this function you go, the more it gets a little bit sort of esoteric with regards to, the look and feel, or the feel, that is, of the character controller and what it can then do, right? So I was going for this real kind of floaty, interesting sonic feel to it. So sometimes when you're kind of close to the wall, even though you're not quite touching, or you've just left, like say you just jumped and you're no longer in contact, or you're just, far enough, and I say, okay, I want to give you a little bit of ability to move, because you're, there's enough wind resistance between your feet and the floor, and there's enough of a vortex that you're creating in there. So sometimes it would wait a little bit, right? So you wouldn't actually be in the air until you exited, and 0.3 seconds would pass, right? So this is where the art comes into the, the character controller. It's just such incredible broad range potentially of, the simplest case to like the subtle differences of what's kind of going on. I also have the when you jump on something that is an enemy, what happens? It checks to see, is the point of contact below? And this would, I guess I must not be using the other one because this would cause a problem if I uncommented both of those out. But this was to say, okay, if you, with an enemy, you check to see the point of contact. Say, okay, if I contacted the player below my center, that means I can do the bonk, right? Add a force, go up, create an explosion, and destroy the object that I bonked, right? So that's how you can have different sorts of behaviors with an enemy, right? So I could push an enemy left and right, or if I jump and land on its head, it gets killed. It gets deleted. We'll get to the camera mover in just a moment. So I'm going to recommend you start with the most simple, perhaps the most simple mover, and just this one we'll just look at for the fun of it. We're like, some of the decisions that went in here to create a quick and dirty kind of Sonic-like controller, where I would do things like rotation was allowed, right? So rotation was allowed in here, but if the player stops moving, stops rotating, I wanted it to automatically say, oh, okay, roll a little bit more or rotate yourself a little bit more to reorient yourself so that you're facing up. So Knuckles doesn't wind up kind of standing sideways. Right. So it'd have to say, okay, I'm slowing down, or I'm within a certain amount where my velocity is almost gone. And if so, set my rotation to be straight up. Right. So it's, at various points I had some slurping, so it kind of roll and then it would automatically kind of teeter until it would stand up again. And then I have a bunch of different cases for, okay, that handle sort of the jumping, what's involved in jumping. All of my jumps are slightly different because the feel is different. If you're jumping from the floor, you're jumping from side to side, you get a much more energetic jump. And if you're jumping from the ceiling, you're getting a little bit more of it's more than just letting go, but it's not quite as energetic as the other jumps, right? So there's the grounded end jump, the not climbing end jump, the climbing end jump, right? So different versions, and there's some different subtleties to each of those. There's also changes to the physics depending on whether there's user input or not, and depending on whether or not you're touching things. So I'm manipulating the drag of the rigid body according to whether or not I'm touching something, so that when I'm in the air, I have very little drag, almost no drag at all, right? I can kind of set this via parameter, versus when I'm touching something, I have real drag. As opposed to relying on friction on individual objects and things, I just decided, okay, crank up the drag when I'm touching an object, and then reduce the drag when I'm in midair, so that I don't have, so that air can I can zip through air a little bit better. And one step further is that I start to manipulate how gravity affects the character as well dynamically. So I'd say, okay, if I'm touching something from above, it means, yes, I can overcome gravity, right? So I am exerting a force equal to gravity in the opposite direction. Right? That's effectively what's going on here. I'm not doing it, so I'm actually adding a force. Instead, I'm just changing how gravity scales, which is a little bit funky, but it lends itself to some cool little side effects. And also, if I'm climbing, I overcome gravity. I'm nearly weightless, which makes me sort of slide down the wall due to gravity. And then finally, we start to get into the situation where the friction, the moment that the user lets go of the controls, more so than if it's just freewheeling, right? So it's got a braking characteristic, but not entirely. It doesn't stop dead. Whereas if you were moving, it would not apply that brake. So it's a little extra. There's always little bits of tuning and tweaking and so on. And then last but not least, of course, is adding the force in the direction that you need to go in. All right, it's the normal kind of force. Oh, mentioning gizmos. There's another little video I did. I feel like it is, but it's not. Is that really right? Because it is only, what time is it? 3:39. Okay. Gizmos. I almost forgot. So gizmos I discovered during the course of this week. I just never used them before. Had anyone else used gizmos before? If you have, feel free to embarrass me by saying, yeah, I've been using gizmos for years. How come you didn't come across those? I've always heard of gizmos in terms of typical usage. You know, gizmos, like, you know, you can use gizmos in your, you know, this is a gizmo. That's how I was thinking of gizmos. So I think that might have been where I got that from. Or, well, no, I forget where first. It was just like some bit of code. Some point, I forget where. Anyway, not important part. It's funny. That's the way it is with these engines. You'll suddenly discover something that you just never did before, and you're like, how the heck did how did I avoid it? Anyway, so it never comes up in the discussion of debug draw. That's surprising. You'd think the documentation for debug draw line and debug draw array would also point you at gizmos, and apparently it doesn't. So that's why I blame it on documentation. But anyway, the thing about gizmos is that you can use them to draw more complex, more interesting debug information. Like here, I wanted to visualize if I was to say have some rays that were kind of at shoulder height, at knee height, and then at various widths, so I could detect, is this foot hitting the ground or is this foot hitting the ground? I could, you know, use those as the jumping off points for the way I was going to cast circles or the collider and things like that, right? Possibilities. So these lines are created using gizmos. I'm using a gizmos.drawLine from a point to another point. You can draw spheres. You can draw solid spheres, wireframes, squares, cubes, all kinds of great stuff. Make your life that much easier. You can certainly get by without ever having used them before, but they are there. They're worth knowing about. So now that I've discovered, I use them all the time, of course. All right. Last but not least, the simplest yet not trivial camera mover in the world. Okay. So I'm going to recommend you try to do something, you know, tune it yourself. I've done a couple of other camera movers where you could say, okay, you triggered a certain action, and then you would highlight something and move to the camera to some other predefined location. So you could set up a little system where, okay, you trigger a certain object, then it moves, the camera goes in a certain direction. You reach the edge of the screen, the camera moves somewhere in response to that, moves to the left, all right? So you can kind of follow the player around. So the simplest yet non-trivial camera mover, like you'll notice in here in the game when I am moving, that the camera doesn't immediately snap and it's not always moving. I think it's important to not always have your camera moving. If you're gonna, if you're gonna create a shaky cam sort of thing, that's certainly, it all depends. So it's gonna look like it's moving a lot more here. You notice at the center, it's not moving at all. And if I move just a little bit, nothing moves, right? Actually move a reasonable amount. But the moment I jump off, it starts to move. So it's clearly following, but then it will settle down and then not move until I reach another threshold. Ooh. Oh, the magnet got me that time. That's cool. Let's see, get down here. Yes. So how does it work? There's a simple threshold for the distance between where the camera's looking and where the player is. So if the player exceeds a certain amount, a certain distance from the camera's location, it says, okay, I need to move the camera then to follow the player until the player is, kind of comes to rest again, or it stays within that area, right? So generally the player is going to be in the center of the screen. And it's a simple matter of saying, all right, I take the distance between the camera and the player and say, is that distance greater than 4? And I could tune this to be whatever I wanted. And if that distance does exceed that, I set a target. So there's always a target that the camera is trying to be centered at, right? It's always trying to be at a certain point. So the target gets updated, and then I basically do sort of a dumb lerp, at that target. So it's not at the player. I don't continuously retarget the player. I only retarget the player when the camera and the player are more than 4 units apart, right? That's when I then start lerping again. And the fancy thing I do here is, of course, I have my vector2.lerp, but then I cast that to a vector3. So it's going to say x, y with a z of 0. And then I add a vector3 that is 0, 0, minus 10, which pushes my camera, makes sure my camera's z value is the negative 10, which it should be in the first place. So that's a super, super, super simple camera mover, right? I could also do things like, say, set a trigger. And the moment that a trigger happens, lerp the camera towards that, right? Set that as the thing to follow, right? So imagine in the case where we had Fred and Durfel, and you could hand off between one and the other. You might have something where, the moment you transfer, then suddenly the other player, you have to, kind of set the other one to follow. Or maybe there's instances where, the player dies and then you follow the enemy for some reason, right? So it can lend itself to all sorts of fun things, right? Other kind of fun things I've been, encourage you to just try stuff, right? Try doing weird things. Like, for example, here, it's something you might not think to try. We talked about, what a pain that is, right? We've talked about things like joints, hinge joints, spring joints, and so on. In this level, one of the challenges, not that it's a real challenge because there's really no real goals in here just yet, but there are certain parts where different physics or different physics materials, so certain things are bouncier than others. This is not a real particularly bouncy section here, but come on, here we go. Come on, Knuckles. All right, here we go. Up. Oh no. All right. Simultaneously can sometimes be the most frustrating but most satisfying sort of. All right, there we go. All right, we're out of there. Now, he's really good at wall climbing and wall jumping. So he can also navigate these. He's fully physics-based, which is important to me because I could drop things on him. And, all of the interactions with the environment, other than the tweaks that I've allowed, sort of all make sense. And even, as he moves, he'll kind of push this tile map that happens to be on springs. So it's kind of weird to anticipate or try to anticipate what's going to happen. Right? That whole tile map, the whole world for that will bounce around, which is fun. See if it's still bouncing. Yeah. That whole level. Loads of fun. So I'm using some buoyancy effectors. I'm using these springs that are attached to a tile map, kind of unusual. I have just a simple hinge joint here that does some rotations. You can imagine having it continuing on that. Have some area effectors that kind of help to launch him. And the one other thing I wanted to mention, then we'll have covered it. We covered in the other class. There's a very, very fakey form of parallax that I'm sort of doing. I don't know how effective it is. Maybe I'm tired of it, and maybe a better background even look at this. And for those of you who are unfamiliar, like a classic animation technique, classic kind of optics technique, and you should see this a lot in Disney, Disney movies, kind of famous for this technique. That as the character moves around, as the camera moves, you'll see it may just look like, I don't know how well it shows up in the stream, but the background is moving, or feels like the background is moving very differently than the camera and the scene. Like you'll see this cloud here, you can see a little bit of a cloud, is sort of always present, despite the fact that I'm moving around in the world, right? That's exactly right. The background is a child of the camera, right? You can, if you've noticed it over here, it becomes obvious that the background there, no matter where I move in the scene, the camera moves and the background moves with it. And the idea behind that is, if you think about it, when you're in the world and you move your head around, or you move around a reasonable amount, things that are very, very far in the distance tend to look like they move far less, right? Things in the foreground move a lot more, right? They give you that appearance because you're more aware of them, right? They're an airplane looks like it's moving very, very slow in the distance compared to an airplane that just flew right past you, right? So I've effectively set the movement of the background to be 0, and kind of creates that little bit of a parallax feel to it. Get fancier with regards to having it move a little bit more algorithmically. So this is one example why I wanted this to work. And I haven't done this yet. So we'll take the hero and we'll put the hero right there. And we're going to take this weight here. I'm going to put this weight right there. And I'm going to, let's see, maybe I should move the hero down just a little bit. Get him touch the wall there. And we'll turn off that. He's trying to hold on there. And it can get potentially clobbered by, things will push him down. We'll see how far I go with fully physics, react to everything in the environment. So that's just sort of my background thing, to kind of create a very, very physical yet pinball-y kind of feel to it. So that is everything for today. And the main thing now is, of course, over the weekend, I'll get grades. I'm going to kind of get them out, rolling them out. If you haven't put things in, like I said, please get things in as you can. I'm also scheduled for my second COVID vaccine this weekend. So I'm getting, apparently the Moderna, which is the one I got, is the one that tends to knock you out for a while after. So we'll see whether Monday or Tuesday happens normally. Kind of warning everybody just in case. I'm going to try to get things done before then. Unfortunately, it's a whole story. But do think about your platformer now. Look at some of the classics. Watch the Celeste video. Watch Super Meat Boy. Look at Braid, Fez. Gris was another great one I just played. Well, I guess now it's been a while ago. There's so many great platforms, and it's all subtle. Yes, Dead Cells. there's all subtle differences to them. And it really is about that character control. So one of the challenges I'm going to put out for you all is, really focus on, don't get carried away with the big world necessarily, because it's easy to just generate lots of, things to jump on and all that kind of stuff. Ghost Knight, yep. Hollow Knight, sorry. Lots and lots of great platforms out there. And demonstrate, do a little bit of camera movement just to kind of get a feel for that, because that also can establish a lot of character, shaky camera that moves with explosions, things like that. Try to get some personality, focus on, how do you want to get your character control? Grease, that's probably right. Yeah. I think it actually means, it's French, and that's one language that I'm not well versed in. I've studied Japanese, I've studied German, I've studied Latin, I've English, and all computer languages, but I've never studied French or Spanish. I've only picked those up little bits here and there. Gray, that's right. Okay, sounds right. A little coffee. I've spent time in Paris. I've spent time in France, but it's funny. Where am I? So don't get carried away with making a big game. Make it just big enough to say, okay, it's more than one screen. There's some more thought in there. Is some progression that goes on, but don't get too carried away. Instead, think about those subtle things that that can make it. And here's where the programming comes in, right? Shouldn't necessarily become overly complex. You'll see, even in the case here, this in my versions, most of the code is just because I did kind of so many different versions. The real look and feel, comes down to, a certain dozen lines of code and how I've sort of decided to design things. Things about deciding when certain physical elements, how they're affected, when things, what is drag like, and so on. So, think about that. Think about, how do you want, as your design, say, how do you want it to feel? Is it swimming? Is it flying? Is it floating? Is it walking? Is the character fast? Is the character slow? Is it icy? Is it hot? Does it feel like you're melting how your interactions with the environment to sort of decide, and then pattern, try to figure out how your interactions with the environment and how your programming potentially affects that. Don't get too carried away. Don't worry. And if it is, just getting some of the basic techniques, that's great too. I think we're, having a great, quote unquote, great semester. I think I'm very happy with how things are turning out for the most part. And glad that we'll be hopefully not having another semester like this. But yeah, have a great weekend. And thank you all for your attention. Okay. Everybody good? Everybody good. Take care. You too. You too.